Welcome to this presentation of the XYRIS measurement metrology tool. In the screen in front of you, you can see two coins, a copper coin, which I'm pointing to with the large pointer, and a silver coin to the left of that. They're mounted on a measurement plane, which is the large black area surrounding the coins. Above that, you can see a measurement head. And within the measurement head, there are two optical sensors, confocal optical sensors, and a microscope. The image that you're looking at is taken from a camera that we're using for the purposes of this demonstration, mounted within the measurement system. The system is enclosed in a transparent enclosure, which is surrounding it here. But as I said, for the purposes of this demonstration, we have a camera mounted within that. So I'm going to move from this camera view. I'm just going to minimize that view. And we're now looking at the measurement screen of the XYRIS instrument. The first thing we'll notice is on the right-hand side here, we have a view from the microscope within the measurement head. And as you can see, it's looking down on a coin. There's a large green box here, which I'll come to in a second. To the left of that is the measurement plane. So this blue area is effectively representing the large black area from the camera view within the cell. So this is the motion area. The current system that we're demonstrating here has a motion of 90 millimeters by 90 millimeters on ultra flat linear bearing stages. So these stages move very quickly and can cover the motion area of 90 millimeters by 90 millimeters. It's currently set up to be centered, and the coin, the microscope image is directly underneath directly above the coin. To the left of that is the parameters that define a measurement. So there are two key parameters here. The first key parameters are the number of points you require in X and Y, in the X and Y plane, and secondly, the area over which you wish to make the measurement. And if you can look at this box here, you can see X and Y are currently set to 4 millimeters, and that's reflected in this area that we've shown here. If I change that, I'm just going to go to that box and change it to 3 by 3. And what you'll see is the green box on the right-hand screen is now reduced to a 3 millimeter by 3 millimeter area. So effectively, what we're doing here is we're combining a microscope imaging system with a confocal scanning system. And if you look to the measurement plane, which has now got a yellow cross here, it's either a yellow pointer or a yellow cross. I'm just going to zoom into this by just zooming the image a bit. This is not changing anything. I'm just zooming the image. This large box around the outside is effectively the field of view of the microscope. And within that, the green box is the 3 millimeter box that we've just requested here. So that's that. So the other thing to notice, let's go back to the overview image, put that there, is on the top here, we've got some icons. We're currently in the microscope viewing mode, which is why we can see this image on the right here. I'm now going to click on a space navigator. What that now does is that allows me to move the system. And you'll see that by looking at the microscope image here. You see I'm moving to the left. I can move in any direction. Let's move to the edge of the coin. Here. I'm going to move down and look at a feature. There's a chain feature here, and let's scroll down that chain feature. And I'm going to say, I'm quite interested in this feature at the bottom here. So this is solely for the purposes of this demonstration. I quite like this feature, and I'm going to make my measurement correspond to this particular area. To do that, I have to switch from, well, first of all, I have to switch off the navigator. So let's switch that off. And I'm now going to switch from the microscope mode to the measurement mode. To do that, in this case, I have to move the sensor a bit vertically. And I'm now in the measurement mode. I know I'm in the measurement mode, and if we look at that of the overview camera, I think you can just about see a point of light here on the surface, which is roughly where the chain is coming down the coin. So let's just minimize that picture and leave it over the top of the, so we can see what's going on. I'm in a measurement mode, as indicated here. I'm going to collect a measurement area 3 millimeters by 3 in the area we selected from the microscope. And I'm collecting 101 data points, so it's 100 spaces by 100 spaces, which gives us a spacing of the data of 30 microns. All I need to do now is click measure. Before I do that, I'll just point to this column here. This is an indication of the sensor output within its range. The current sensor that we're using, it's not visible in the camera view, but it has a full-scale range of 350 microns. And you can see it's roughly in the middle of that range. To the right of that is just an indication of the amount of light that's being returned to the sensor, which can be used for various measurement principles if you wish to use that. But we're currently measuring height, property, and all I'm going to do is click measure. So that opens a screen. You can see I've got some measurements here. I'm just going to save today's measurement 3 by 3. It has the date on it. I'm going to save that, and it's starting to measure. Now we can see something is happening on this screen, which I'm pointing to below the measurement plane. There are two things happening. The first thing that's happening, if we put the camera view on, let's go here. Let's make that bigger. We can see the point of light moving on the surface. Here. Let's minimize that. We can also see the measurement time. Currently, we have 30 seconds left for this measurement. And you can see the square 3 by 3 here is gradually being filled with data. We can zoom into that in a moment. We can't zoom in while it's actually measuring, but we'll zoom into that in a second. And here we can see a live feed of the cross-section with the height given in millimeters, but you can see the decimal points here go below a micron, goes to the nanometer scale. So this is actually giving us an indication of the features that we're looking at. It's telling us that we're getting good data, and we have some parameters here. We wish to use those, we can. So the measurement's finished. That was the noise that we heard. I'm now just going to use the zoom function like I did before. Let's recenter that. And you can see pretty much we've got the measurement area that we were looking at. If I go back to the microscope mode, let's do that quickly. I need to adjust the sensor to bring it into focus. Sensor height position, that is. So there you can see a very quick measurement that we've done. And you can see the corresponding area in the microscope mode there. So that's a quick measurement demonstration. What I'd like to do now is I'd like to say, well, I'm quite interested in some other features here. First thing I'm going to do is I'm going to reduce the size of the measurement area. I'm going to reduce it to 1 millimeter by 1. I'm going to use the same number of data. So now the grid spacing has reduced from what was 30 microns to 10 microns. We have a smaller area, and I'm going to say I'm interested in the features, this kind of whole feature around the red area. Now remember, the image that you're looking at here is actually a height map. So we can look at this. This is data. We can look at this in a piece of software we call BEX, which we'll do later here. But for the time being, we're just going to take this information and say, well, actually, this is the area that I'm interested in around this this enclosed region here. And I'm going to measure that. So the first thing I need to do is, because I changed the focal point, I need to bring it back into focus. So the data is now valid here for the sensor. And I'm going to hit measure. Here's the data file. It's 1 by 1. All the information is saved there. And now you'll see, because we've zoomed into the image, we can see the data filling up the box, which is now 1 millimeter by 1 millimeter. And again, we can see the corresponding cross-sectional information as it's being scanned here in the image below. If we go back to the camera view in the cell, you can still see it moving here. Let's make that bigger. We have 20 seconds left. You can see it's here. The light is focusing on the image. And let's reduce that again. And you can see this area is filling up. So 5 seconds to go, the timer is here. You'll hear a noise saying the measurement's finished. And there it is. Okay, so let's zoom into this. So we're zooming in now. We're going into much closer detail about the image that we're looking at. For this final part of this quick demonstration, I'm going to show you an advanced feature of the measurement system. But let's start off by deciding, let's reduce our measurement area further. Let's reduce that to 0.1. So we're now measuring 100 microns by 100 microns. And I'm going to say, well, there's a little feature here in the middle, which I'm quite interested in, like a dimple of some kind, or a hole. I'm going to measure this area. But actually, I'm also interested in a feature here and maybe a feature here. So how do I do that? Well, I'm going to do all three measurements at the same time. So what I'm going to do is I'm going to use a tool, which is shown here, that allows us to actually program the instrument to do automated measurements. Let's look at the value. We've got 100 spaces, 101 data points by 101 data points over 100 microns. So the grid spacing is now 1 micron. The sensor is in range, it's here. What I'm going to do is I'm going to add that to a measurement, and you can see that's come up as number 1, just using the add function here. But I'm also, as I said, interested in this feature over here. There's a little dimple or some feature here. I'm going to add that to the measurement. That's number 2. And I'm also interested in this edge feature. So let's do that. And I'm going to add that, and that's going to be measurement number 3. So 1, 2, and 3. I'm just going to automate the measurement by clicking this function. I could vary the size of these boxes. They don't have to be all the same size, but in this case, I'm just keeping it simple so that we, for the purposes of this quick demonstration. So if I just click here, you can see it's actually started measuring. It's got 43 seconds to do the first measurement, and you can see this box gradually filling up. If we go to the camera view, it's hardly visible that this is moving now, but it is moving. Remember, it's only moving over 100 microns, so 0.1 of a millimeter by 0.1 of a millimeter. If we increase the size, maybe we can see that. I think it's just visible here. So this is moving. Minimize that back again. And this is the first, you see the number 1 here on the end of the file. It's the first of the 3 measurements. I didn't name the folder. It's just all, it's gone to a default name, my job. 4 seconds to go. And that's completed. It's now gone to the second measurement. So it's actually measuring here. So this moved from the measurement area here to this measurement area. And we'll see the game. If you keep an eye on this, you'll see this move to 3 in a few seconds, in 30 seconds. And currently this file is called file number 2. It's gradually filling the box. As I said, I'm going to finish off. We'll look in a bit more detail at maybe one of these features in the BEX software processing, software analysis package, which is tied into the XYRIS instrument. So 8 seconds to go on this one. See the cross-sectional information beneath, and it's now moved to number 3. So what I'm showing here is I'm showing a very precise, accurate system, which is allowing us ultimate flexibility in a measurement plane up to 90 millimeters by 90 millimeters. And we're able to control, if you want, the magnification of the image simply by controlling the amount of data and the size without changing any optics. So this is an incredibly powerful instrument for doing analysis of any features you want on pretty much any surface. Okay, let's finish that off. That's 3. And that's now completed. If I would just switch back to the, let's reduce that. Let's switch back to the microscope mode and bring this into focus. You can see that actually that last box, I think you can see it's just about visible at where my pointer is on the edge of this feature here. Right, let's try to complete this by just opening the last data set. Should now appear in BEX. Do that. BEX is opened up. It's on the lower toggle here. And you can see that I'll put that in a plain view. This is not a demonstration on BEX, but you can essentially see the edge feature now. And if we look at the cross section here, we can see the detailed information. Now, this piece of software is covered by a whole range of videos. I'm not going to introduce the software to you here, but basically you've got all of the functional tools you would require to really analyze this surface, including roughness parameters, 3D parameters, 2D parameters, cross-sectional information, etc. Okay, let me just minimize that window and conclude the presentation by saying thank you for your attention, and I hope you found this interesting. There will be a follow-on video where, if I go back to the overall camera view here, I'm going to look at the automated measurements of these two different samples within the same measurement program.